Welcome to Unlimited Idea, your go-to destination for all things 3D printing and laser engraving. I'm Sam and I'm here today to talk about TPU and see how we can print them flawlessly. We have been there that we want to print this kind of filaments. There are very stretchy and they are very soft, but the problem with the bowden tube is we need to reduce the speed, and maybe we need to add the increase the retraction, because this filament is very stretchy, and when it's in the bowden tube is pushing through the bowden tube. Imagine we are pushing 30 centimeter or 300 millimeter this kind of material against each other. It's because it's like rubber band and it's very elastic. They are putting a lot of pressure behind the nozzle, and when we are retracting, still we have some pressure there, and it's causing some stringing. So the best things for the printing for this type of filaments is direct drive. But how we can add something like that to our printer without spending a lot of money is just printing a piece of adapter for the stepper motor extruder and the wheel here. That's it. If you are using the original fan system for the Elegoo, that's enough. Just you can attach it here and connect the whole system here, and you are done with the direct drive, and easily you have a direct drive printer. But the downside it is we are adding some weight to the extruder, and if you follow me during the video, we can see and discuss about it. But if you are using this kind of fan blower that I updated in my previous video, you can't use the this print for this blower, because here we have a piece, and this fan head is not here, it's there, and these two and it's hitting the blower. We can't attach the this piece and the blower here. So I update this blower. I cut off these pieces from here at the top, and also moved this one from here to here, and also I add some angle to this one. I add some angle to the blower path, that when we are footing this one here is not going to hit the blower, and we can install it. Also, I found some other adapters for the motor, but it has some downsides, and let me to bring the printer, and then I can show what issue I found with this one. First, let's talk about this adapter. As I said before, if we try to put the this piece here, and these are going to the wheel, and behind here we have some spaces for the screw. It's coming from the other side. We can put it here because this blower fan, it is middle of the way, so I cut this piece, move it here, and rotated a little bit of the blower fan here. And about this design, the good things about it, it's sitting middle of the wheel and the extruder here, and we need to replace it with the this spacer we have here, and it's stay there. The downside with this design is the 1/3 of the motor is other side, and if it goes the end of the printer is going to hit to the Z axis or this side. Because of that, it's not this piece is not contacted with the Y stop, so they added a piece of extension here. It can hit the Y axis and Y stop here. In this way we are losing a little bit of space. Otherwise it's a good design. I like this design, but the problem it has, we are losing some space from both sides, maybe 10 millimeter from each side. It means we can print 20 centimeter or 200 millimeter with the direct drive with this design. Another issue we have, if we add the motor here as a direct drive, we are adding some weight on y-axis, and the other side, because we don't, in this type of printer we don't have any support like the other side. We have a Z screw. It's going down a little bit. It's not that much, but still we are putting some weight here. Also we are putting some pressure on the motor. I'm not sure how speed we can go with the with this type of direct drive, but we will see in our test. I printed these two to show you how far it can come down. If I put this one here, I'm not sure how much I can show in the video, that how much is going down or up. If I put the stepper motor on the y-axis, it's going down maybe 0.5 millimeter or so. It's not that much. If I take it out, the y-axis is coming up. For replacing this blower fan with the new one, I need to open the whole blower system that we can replace it. Let me to open it and replace it with the new one. Now for assembling the pieces, I'm going to first connect the blower fan, then open the extruder motor and install it here. Behind the camera I attached the build touch here because it has a teeny tiny screws and it's very hard to take a movie and connect them. Let me to connect it this new blower connector here, and then we are connecting the blower, then the rest of the system. Now I'm going to install this one here. These holes are going and sit on top of the spacers very nicely. And then I need to open the extruder motor and install it here, but before that I need to take out the pipe here. I should have done that before. Now for opening the extruder motor and putting that here, we need to open 4 screws around the motor, and they are tied with the gear here. Now we open the whole motor system. We are able to connected here in this position. This time I'm going to put piece of PTFE tube inside here, and with the Sharpie put the sign next to the keeper. That piece of plastic is keeping the PTFE. And then I'm going to measure it from the measure this distance. It's more or less about 28, and then I'm going to do the same things for the extruder gear. I'm going to put it inside and mark it with another Sharpie. And then measure it again to see how much we have. We have almost the same. This one is 27, 28. We have 228 millimeter, and distance between these two I'm going to eyeball it. I'm going to put the PTFE inside the nozzle and put the gear here, and I'm going to try to measure it with the depth. It show about 10 millimeters. Then I'm going to set my caliper to caliper. I'm going to set it as 6.7 and cut the piece of PTFE, and then if we have it more, we can cut it a little by little to make it as the size we want. I got a piece of PTFE. This one is 6.7. Then I'm going to put it inside the nozzle here all the way down, and then I'm putting back on the gear part. As you can see, they have some distances. For this part, I'm going to measure the distance between two screw hole we have here. It's about 11 millimeter. I shorten this PTFE tube 11 millimeter, and now it becomes about now it becomes about 61 millimeter. This size it is for my design and my setup. Maybe it's different for you. Just you need to find the right size for it. I'm going to put the PTFE tube here, and then I need to secure the PTFE. Then I'm going to put the gear here, this piece of gear here, and connect the motor here. While I was testing the mount behind the camera, as you can see, this mount it came out from the TFE tube. I find two reasons. One, the teeth inside here, they are damaged. I need to replace it. Also, I found another issue because this one is sitting on wheels. If we have some pressure, it's coming off. If these teeth are working properly, still maybe it can cause some issue, because sometimes we have a lot of force behind it by the filament. It's pushing and pulling into the extruder. So I came back and redesign this one to combine two different things. As last time I show you, I have this type and this type. I combined these two and I redesigned the original one to this way. It looks like the first one, but this one is a little bit thicker here, and we have a hole for the wheels. I need to open the top wheels and pass through the bolt here and there, and tie it there. I think this time it's going to better. I'm going to test it and we will see how it's going on. This time I'm going to put the motor here first, and then I'm going to connect it to the rest of the printer. I installed the motor and the extruder gear here on this mount, and I found some issue in this one. Before releasing the STL file, I'm going to fix that issue, then release it while I'm releasing the video. For the installing the mount here, I'm going to lose a little bit this nut here. and this screws and both for the wheel fans. Both sides is going to do on the opening. Then I'm going to open this from this side. With the new one, we don't need this spacer anymore. I tried to make them the same size. For putting this part together, we need to remember to put the PTFE tube inside the PTFE holder and push it in. Also, at the same times, we need to match the hole here and push the whole part to the gantry. It's a little bit tight, but you can manage it and push it in. Now you can put the bolt here and the wheel, then the nuts. Also this side and the nuts. And just one thing I can suggest here: if you are printing any parts for your printer, please print a spare part, because during the time maybe they are breaking or they are going to damage. If you modified your printer and you don't have that one, it's your printer is not working. You are going to have a lot of work to make it as simple as possible, like the one you bought. Now we need to tie the nuts here, under here, because it's a little bit wobbly. Now it's very sturdy and it's not wobbling anymore. Now let me to put together the bluer, and then we can continue with our update. One of the changes we have here, I moved this handle from the back to the front, and I little bit bend the bulwark fan. In this case, in this way, it can stay a little bit forward and is not hitting the motor here. Now, one thing we need here, now because we change the motor position from the back to the front, the original wire is not long enough that we can connect it here. We need a extension cable that we can add a length to this wire and connect it to the motor. We know this cable are working and they are matched with this motor. If you change this motor to the pancake or the other type, maybe they have different pins. In my first video, I show you how we can say which one is which and how we can connect it. Or if you are getting a cable and the middle one there are cross, maybe you need to double check it with the motor and your cable. They are not cross, or maybe they can burn your board. And this part you need to have more attention. This cable, I pick it up and they are straight and they are not crossed. If I replace the motor with some other brand, maybe I need to cross one of the middle one to match it with the motor configuration. Let me to connect this one here, and I'm going to pass it from here. Also, now it's long enough, we can pass through the whole wire through the harness and get and bring it up here and use it. In this way we don't have to lose wire and the harness here. Right now for our test, I'm going to zip tie it to the harness, and then I'm going to move it inside the harness. And next thing we need to take care of it is the filament run out. We can bypass it with a piece of filament. Just we can put it in and think it has the filament, but we need to make sure we have the enough filament for our print. Or you can print this one from Thingiverse and add it at the top of the gantry, and connect the filament runout to this one. For this video, I'm going to put this one at the top, and I'm going to show you how I did. Another things we need if we are moving this one at the top of the gantry it's an extension cord for the extending the wire from and the old place to the new place. Pins EX 2.54, and one side is female, another side is male. Let me to first move the filament holder here from here, because as you know, it's back of the gantry. When we are putting the filament, it's going to the back, and our motor right now is at the front. I'm going to reverse it and put it to the right side of the printer. In this way, the filament can come down to the motor. Now if we put the filament in the filament holder, it can go down to the motor here. But if we are putting the filament run out here, we are passing through the filament run out, and it's going down to the printer. It has some advantages and disadvantages. One of the advantages is the filament is coming down straight, just it's going these directions. But the problem I found with this one, when the PTF is getting shorter, maybe is a scratching here, and maybe in the long time it can cause some issue here. I'm going to think about it and how we can resolve this issue in next video. For right now, I'm going to put this one here and test out our printer to see what the result we are going to get. But you need to remember that we moved a lot of parts here, and you need to relevel your printer, especially if you have a BL Touch. Here I have some samples before and after direct drive. This is the Boden tube, and this is the TPU filament. This one is printed in 60 millimeter speed, and the other one is 100. This one is 60. We have some stringing here, and this is 100 millimeter per second. Still we have some stringing here and there. And here I have other samples after upgrading to direct drive. This is the 100 millimeter per second, and this one it is 60 millimeter per second. Still I have some stringing, but if we compare it with the Boden tube, we have less than the other one at the beginning. If we compare it, the left side is the Boden tube and right side it's a direct drive one. Both they are printed in 60, and if we compare it with the 100 millimeter per second, still we have something, but with the Boden tube we have a little bit more. Also for other testing, I print the another one is with the direct drive, but I reduced the speed to 40 millimeter per second. But still I have some stringing. I'm not sure this is related to the TPU filament, or it needs some adjustment. I'm researching to see what's the issue and resolve it. Also, I printed this tower. To see how good it can print. At the top, as you can see, it's not round anymore, because when it's printing, and this type of filament is flexible. when printing, it's bending a little bit of the structure and is messing up after this part. I did the same things, the same print, the same G code with the direct drive, but the result is the same. This one is with the direct drive, the left side is just the body tube one. In this case, it didn't help when we are increasing the Z. But strange things I had when I printed this test for the Z, it caused some effect here. Please in the comment let me know if you know what is the issue and what caused this result, because we didn't change anything, just we moved the stepper motor from the back to the gantry. Also, I printed this speed tower, but right now it has some artifact here that need to be resolved. As we wrap up this 3D printing and laser engraving adventure, I hope you have gained some valuable insight and inspiration. Remember, the sky's the limit when it comes to your creativity. And once again, this video is not a sponsor. If you enjoyed today's video, don't forget to subscribe, like, and drop your thoughts in the comment section. Your support means the world to us. Until next time, keep creating and inventing, and I will see you in the next video.